Dear friends of the best game in the world, today I want to deal with the Logic Motherboard, which allows us to check for states. For example, is the arc furnace on, or is the gas sensor saying the pressure is high or whatever, and then to act upon it. And let me preface this by saying that it absolutely sucks and you shouldn't use it. But I want to go into this anyway because, well, I'm curious, and someone on YouTube actually asked me this. They are wondering if they can put arc furnace box in their station and use the Logic Motherboard to automatically evacuate it, but not leave the active vent on all the time, only when there's gas in there, and maybe also turn it on automatically if there's ore present. And yeah, let's try that then. And later we do the same in MIPS, which will be so much better. Okay then, create a new state. Scroll wheel is slow as per usual. I really don't understand why Rocketworks is not putting in the 5 minutes it takes to put a multiplier in there for the scroll wheel, which would make the interface wherever you can use the scroll wheel so much better. I'm sorry, I have to say it like this. That is my feeling and my experience of many years of programming. That would be all it takes. You know, just multiply it by 2 or by 4 so that the suffering is diminished. They're not doing it, that's sad. Otherwise I can only applaud for all the things they're doing. Yes, I admire them and I can say I love them. But critique where critique is due, right? I'm not a fanboy. Okay. So here we have just made a state. We can make another one if we wish. What is a state? Well, here we can set conditions, and the little box, the little check mark here tells us the condition is currently true. If it would be an X, then the condition would not be true. That the condition is true is not a surprise because we don't have any yet. So there's nothing that would say, maybe not. It's always true. And then we can also have an action here. And then we can say go to the next state. I don't know exactly what this means because I find this whole thing rather confusing. Not because I'm like because I didn't test it enough or because of the fact that it's just not documented, but because I tested it and the logic just doesn't check out. It seems to be implemented incompletely. So anyway, we can put a check here. Let's check if the arc furnace gas sensor's pressure value reports something that is greater than 0. Sadly, we don't have greater than equal or less than or equal. We don't have that. So yeah, anyway, so you see, it just flipped to that. The pressure is not 0 because I just set this up, you know. So we still have the room atmosphere in there. Therefore, we have pressure. And once we suck that out, it will go through a pipe here into this thing. We'll gather all volatiles in there. And what remains comes out here and will be filtered for volatiles and will be filtered for N2O. And the rest just comes out here because that can only be oxygen or CO2 or nitrogen. And all of that I would like to have in my atmosphere. Okay, condition greater than 0, and if so, then we want to turn the arc furnace vent on, value 1. Confirm. Now you wonder why it's not yet starting. Okay, a few seconds. I swear it feels longer when you wait for it. So, greater than 0, then we want to turn that thing on. And I don't know why that is not currently happening. I mean, I can click play here, maybe that's what it is. But no, that's not what it is. I guess you can only click play on a thing that is not yet already yellow. So let's make a new state. And let's go up here where it's not yellow and click play. Now it's actually running. So that's actually the thing, and now we can actually see that there's no longer gas in there. Yeah, what do we want to do if this is not true? If there's no gas in there, then we want to execute state 2. And you see it is already jumping down here. That is good. That is promising. And here then we want to turn that thing off. And do we want to have a condition? No, we just want to unconditionally turn that thing off when we arrive here. See, this thing will go back to itself when go back to itself, state 1, but only when it is false it will go to state 2. Is what you think. I mean, currently we're thinking, oh, that's nice, that's cool, you know, the interface is kind of speaking, but you will actually realize it doesn't fucking work. It doesn't. Okay, let's continue. So the action that we want to take here is we want to we want to turkey the arc furnace vent off. Setting, we already set this. It's already there. It's not happening though, I don't know why. Maybe we should go back up here and click here. Oh, now it worked. Okay, alright. So we might think, oh, he's full of shit, it's actually working. Is it, though? Because now, this condition here will no longer be checked, for whatever reason. Let's toss something in there. And turn the thing on. Let's make sure that we're not mistaken. Here we have there's nothing, and... oh, there's nothing. Alright, it was pumped into the room air. Yeah, okay, so this is empty, that is empty, this is empty, and the thing is off. You see it is glowing. And now it spat something out. And there's no gas in the room. But you see, sadly I'm right, I wish I wasn't. But then again, the amount of tests I made, I would actually not like if it would have worked this time, because that would just add yet another factor of unreliability, you know. But now at least I've kind of spotted the pattern. So let me show you what to do. So there's pressure in there, but it's not activating. For some reason it is not activating. Here we're saying condition pressure greater 0 is fulfilled, then it should turn that thing on, right? And but it's not doing that. Oh. Damn it, there's so many factors to consider. Okay, I done goofed. I mean, I'm probably right still, but we have to say that the next stage shall be 1, I think. Yeah, let's try that again. So, play. It's pumping and it's not stopping. See, it's unreliable, it doesn't fucking work. The condition is no longer true, so it should stop. It is saying it would go back to itself if the condition would not be false. We have seen that. But now it goes to state 2 since the condition is no longer true. I mean, see here we have no longer pressure in there. And what it should do then, unconditionally, is it should turn that thing off. And we have seen it do that. And when it's done, it should go back to state 1. But it's not turning it off. I have found that if you add a condition here, that actually helps. So let's check the gas sensor, pressure equaling 0, which is currently fulfilled. And then it should turn that off, but it doesn't, because I guess maybe we have to click play somewhere where it's not currently yellow. So let's wait until it's not yellow and click then. And it still doesn't work. What is happening? How does this work, man? This is so unreliable. Turning off and on again. Yeah, well, okay, my conclusion was that for this thing to actually work, it has to point to itself. Here, state 1 has to point to state 1, else it will not evaluate the condition. And here for state 2 to work, it has to point to itself yet again, so that the condition, aha, look at that, it turned off. So now that we have a condition here, we can falsify it by tossing something in. And turn that on. And now it turned on, and now it turned off. So I guess now we have what we wanted to achieve, right? Turn it on. Come on. Yep. Alrighty, let's let's revisit this. Let's look at this. So we have to create a state. Now we have a state. In this we check if the pressure is greater than 0, And if it is greater than 0, then the action shall be taken, turn the vent on. And the next state must be itself, else it will for whatever fucked up reason not execute that. I don't know why, and I don't know what this is even good for. If the condition is false, we go down here to state 2, which we also have to create, and then we turn that thing off. But we have to... Anyway, we need a condition here. I tried it, you can try it too. I mean, you will ultimately realize the guy's right, or maybe you will find a way that it didn't try. But I think it has to be done like this. You have to have a condition here too. Basically the mirror partner of the other one, stupidly, even though that is already clear. If it's not true, it must be false. If it's not false, it must be true. So MIPS is really so much more convenient, even the logic chips. And then it has to go to itself, else it will not evaluate that. And if false, then we go back to 1. Okay then, can we also weave the arc furnace itself into this? Can we automatically turn this thing on if there's something in the input slot? Well, let's just add another state here and check for the arc furnace, which will then now be very awkward because the interface here is completely fucked up. If I release the mouse now, the same thing happens when I added the sorters, but that's just the way it is. I have to put up with this for now. Arc furnace test. We want to check if... Yeah, we cannot check the slots here. That's also annoying. We cannot even do that. But I can check, for example... if the thing is idle. I can check if it is idle, and if it is idle, it shall not be idle. That's what I can do. What I can also do is I can check for the reagents? No, for the recipe hash. That is someone showed me in a YouTube comment of one of my videos. If you check the recipe hash, then no matter if there's something in the import slot or something is currently being smelted, the same recipe hash will be shown. And so, yeah, that is helpful. Is not 0. Arc furnace test, recipe hash is not 0. In that case, we want to activate that thing. Activate on. For some reason we don't have 0 and 1 here is completely inconsistent. That thing is really incomplete, so you shouldn't use it. Okay, and once we have done this, we need to go back to state 1, I guess. And now it's hung on state 1. And that's a problem, because now it will not activate, even if we toss something in. That sucks, right? We cannot use it, we cannot do it like this. I mean, I can go to state 3 and just stay with state 3 or something, or not. Let's try something. Yeah, let's say we stay on state 3 constantly, but we go to state 1 afterwards. Let's see what would happen. We want to go to state 3 so that it is even invoked. What happens? Okay, this is annoying. Now it's stuck here. So I guess, I mean, if we want to do this, we need a second computer, really. We need a second computer that constantly needs to be running, because this will not, this Logic Motherboard will not do anything while the computer is off. I tested this, it is definitely so. So we need a second computer just to do the activation of the arc furnace, so it's really annoying. Okay, toss something in. It's not working. Yeah, because I said next state is 1. We have to point at the same thing, else it will not execute the condition. To demonstrate that, let's press play again once this thing is not yellow, and oh. Why is this not on? Recipe hash, not 0. Okay, then let's not go by recipe hash, but by idle. Could you be any slower? Idle is 0. If idle is 0, then activate, please. So we have to click play again while this thing is not yellow. What's happening? Why is this not activating? Is there nothing in there? There is something in there, else it would say there's nothing to smelt. See how bad this thing is? You don't want to use it. You really don't want to use it. Do we need another false state thing? But then we'll never get here. I mean, forget it, okay? I mean, it can kind of be used, but then you will need multiple computers. You know what? I'm so pissed off by this thing. Oh, I don't have enough copper. Ah, okay. Let's do this whole thing in MIPS. Blissfully, gloriously, easily. Define hash structure arc furnace. Yep. Now it's smelting that happily, and if I interrupt it, you hear it keeps going. Now let's read the gas sensor, which has a name. What's the name? Arc furnace gas sensor. I cannot use batch reading here without a name, because else I would get all kinds of gas sensor data here. Load batch named into register R0. Thanks. Test. Pressure. Some. Whatever. And then we... Well, basically what we can do now, it's a bit dirty, but let's just do that. We can just say SBN CLS vent ins vent test on R0. R0 will now have a value that is 0 or 0.1 or 0.2 or 7 or 1000 or whatever, and if it's 0 then it will mean false. And I think everything above 0 or even below 0 probably will mean true. So we will just write the pressure itself into the on of the active vent, and that should then just turn it on accordingly. I mean, alternatively we could just say SGT R0 R0. This will write into register R0 a 0 or a 1. It will be a 1 if R0 is greater than 0. Alternatively, this is the same thing. So then we will just turn this thing on, else it will be 0. But let's try without. Define class vent hash struct active. Define ins vent test arc burn vent. Actually, I don't know what the name was. Arc fern vent. Not the best name. Okay, confirm. Do we have something in here? A little bit, yeah. This is 2.99 moles and nothing else-wise. Export. Nothing's happening. Why not? Is there nothing in here? There is something in here. So maybe my thought was wrong. What's the pressure? The pressure is 841 pascals, and the values that we read from the gas sensor are in kilopascals, so we are at 0 point something. Maybe 0 point something is too low to count as a logical one. If so, then this should fix it. I must be doing something wrong. Are we even writing to the right thing? Mode 1, we want to suck from that little room. Come on. Export. Yes, we are. So I must be doing something else wrong. Arc fern gas sensor. Arc fern, gas sensor. That was the mistake. And let's take that out again to just see if this works. Export. Okay, and now we're at this 0.1 problem, I guess. Now it's turned on. Okay, 0.1 is too low to count as a logical one, is what we just learned. The question is, I think it was it was 800 pascals, right? That would be 0.8 kilopascals, so it is not being rounded to the nearest integer, but they are just checking if it is less than 1, then it doesn't count. Okay. So this will suck the room dry if need be. Yeah, now we no longer hear the sound because there's nothing more in there. That was easy, huh? Automatically turning on, automatically sucking dry. That's simple. And you could have done it even more easily. Yeah, well, for example, I could have used a dedicated logic network for this one, where there's nothing on this network but these devices. Then I wouldn't have to use the named approach. Then I could just do this and leave this out, and then respectively also leave this out and that. That would have made it easier. And then I could also have, what I could also have done is this. I can delete that and just write the actual number right here. So let's test that. Actually, I will make the configuration cartridge. Configuration cartridge. We need copper. Forbidden copper. What you just heard in the background is my automatic station cooling, which you saw in video 1, which you saw, I hope. So. So, let's look at this device, if I can manage to look through the window. Here we can see all the properties it has. We cannot see the slots, but we can see the reference ID, which you think is like -1735686 or something like that, but no, those are the hash numbers of devices in the game, which for whatever reason have these large values. The reference IDs are usually lower numbers, and every object, I think really every last object in the game has its own objective number. That is not a feature I think they put in there for our convenience, but really just as part of the programming. They have to manage things in the background, and this is, you know, they're exposing this value here. And you'd think it would be a number like 1734 or something, but you can also write it in this hexadecimal format. Hexadecimal uses 16 characters instead of 10, or 16 digits instead of 10, so we can write numbers in a shorter form. 4BF4. So let's try something. Can I turn this off? Yes, I can. So the source code is not yet doing that. 4BF4. S directly $4BF4 on 1. Confirm. Export 9er. Where is it? And you saw it just turned on. So we can address that thing directly. And if we do it like that, maybe we still want to use an alias, not to get lost in translation, you know, but now we're actually not writing to all arc furnaces on the network, but only to this one. And we also want to activate it, which means that we can remove this line. I don't want to go there generally in programming, right? But I want to demonstrate what's possible. So the event, what is its value? Its identity? 5B, 1B. B1B, mode 1. And this means this. The gas sensor can also go away, because its identity number is 5D56. Load directly. Okay. Everything should now work like we had before. Export. Okay, there's something wrong. Let's see what it is. Incorrect argument count at line 7. Load directly into register as a... Oh, right, it's a load directly, it's not a batch thing. Alright, this everything should be working like expected. Yeah, this is being turned on against our will. This is glowing and glowing, so it should be smelting, and it should also do that automatically. Alright, let's see how short the source code is. Turn the thing on. Activate it. Set the mode of the active vent to 1. I would prefer to do that before turning it on. Then load the gas sensor pressure and turn the pressure value into a clear 0 or 1 situation, and then write that into the on state. We can also do alias, not alias, define arc furnace like this, which is still short enough to be justifiable for those who really want to keep their shortcode source. And this is the you actually have to think about this. What is this? Well, you should use names if possible. Let's make sense of this. Okay, we exported successfully, and now we should actually be smelting. Is it glowing? Yes, it is glowing. Is it turned on, being turned on? Yes. Is this working? Yes, it is, and it's turning off automatically. So that's the shortest reasonable version of that source code, I would say. Okay, while we're at it, shall we do something else? I wouldn't know what exactly, but let's walk around, see what happens. Here we can put a chip in here, and when we say SB to write something to the housing or to read, then this will affect this device. And these things, filtration things, are really cool because they know the pressure on the input side, on the output side, on the other output side, and even the gas mixtures. So yeah, that can be used to control the thing very conveniently. Anything else? We used the Logic Motherboard and realized that it's shit. We did the thing with MIPS. Should we also go through the effort of doing all of that with logic chips right now? I'm not a fan of that, and that will make the video fucking long, but I mean, you can just stop watching the video then, yes? Okay, let's turn this off and do everything with logic chips. This will be awkward. I never do this. Might not have enough space to do it. So we need logic chips. And we need copper. More than we have. 41 grams should be sufficient though. Gold we do have enough, I think. So let's see, what do we need? Let's set this up on the wall. We will definitely need a logic writer to make the arc furnace glow. I will also use a logic reader. I should rather use a slot reader to find out if something's in the slot, but I want to follow this tip that I got to use the recipe hash, which I think might be safer, or not sure. No, let's go with the slot reader. Batch slot reader. Slot reader. So first that thing shall be... Oh, and it shall be turned on. Yeah, let's do that too. Logic writer. All of the things. Let's do all of them. Didn't I have cable on me? I did. Actually don't know. Where's it? That's the input? Huh. Should have checked before. Well, a few extra cables, who cares? Yes. For whatever reason that I can't explain, I'm a bit nervous. But it's not going to be stage fright after all this, I don't think so. Hey, let's not waste all the copper. Okay, all of them on. Well, let's turn them off while I'm configuring them, that would be more wise. Hey, why can't I click this? It's on the inside. For whatever reason I cannot click it. screw that. So, okay, batch writer. I put up the batch writer. Damn, I wanted to put up just a logic writer. Anyway, okay, so what we are targeting is the arc furnace. Huh.
Welcome to Exosphere, the dark side of Synthera.
This is the test arc furnace, and the output variable that I want to write is activate, and as input chip I want to set, well, the slot reader. That's going to be an adventure because there might be multiple. Ah shit, that was already. Slot reader. Okay, we have the slot reader. The slot reader now must be assigned to the arc furnace once more. And the slot we want to read is the import slot, and the variable that we want to read is whether it is occupied. This now reads that, and does it show the value? It doesn't. Logic writer, turn on. And now when we toss the when we toss something in there, it should actually turn on. That wasn't right. It doesn't turn on. What's the reason? Logic writer. Oh, I haven't yet assigned the source. Or did I? Slot reader. Slot reader. Yes, I have assigned the source. Arc furnace test. Import. I have set it up correctly. I don't know what's happening. Why is it not activating? Oh, because it's not on. Hilarious. And that's one of the downsides of the logic chip solution, because the logic writer will only write once. The value will not be repeated. So yeah. Let's try that again. Yeah, it works. Okay, we need a logic writer to do the activate. We need a slot reader to read if something is in the import slot. Now I want to make sure that this thing is definitely on. Really? I disagree with this implementation. So we need a logic writer. Logic writer, here we go. But does this help? This will only write the on value once. Interesting problem. I have a wicked idea to solve this. In case it works, it is indeed an idea I just came up with. Wasn't prepared for this. So as input value, I just want to read the daylight sensor. What's its name? Daylight sensor. Wait, did I already run past it? What's happening? Why is this thing not on the network? Isn't everything connected with everything? Yes, it is. I'm stupid. I first need a logic reader, of course. And again 1,000 cables. Do I even need one down here? No, there is nothing there. There's something on the right. You can always see, you can always tell by the color. These ports of course have meaning, but I don't have to care about the meaning in my current network setup, so I will just connect everything and forget about it. Yeah, of course you cannot select the daylight sensor, because the logic writer is only for writing things, and the sensor cannot reasonably be written to. Daylight sensor. The variable we want to read is the vertical angle of the sun, which is constantly changing. Therefore we will have a constantly changing value, which will always be above, will always be non-zero, except when we have noon. Only during noon this thing will not work. I know it's crappy, it's not the way I would implement this. Obviously I just use MIPS because I can, and so shall you. But anyway, now this thing needs a name, because I'm getting kind of confused with all my logic readers. LR day angle and LR input slot. So the logic writer shall read from this one, LR day angle, and it shall write to the arc furnace, and it shall write to the on value. Okay, arc furnace test, on value. Let's turn that off. Turn the reader on. Actually, no, let's turn the writer on first, see what happens. Hey, wait, is this... There's the day angle. Okay. Has it turned on? No, because the value currently to be written is 0. But now we get the value 92. If I can get this thing to turn on. Haha! It turned on. Let's see if I can turn it off. That's what happens? This is hilarious. You just have to have a constantly changing value. It's too bad there's no random generator chip, right? Or is there one? I'm not aware of. Of course we have a random generator. In here MIPS can do everything. It also does the dishes. But this one, yeah. So we have a constantly changing value, so that thing is being turned on. Glorious me. And so it is ensured that we will always have that this little glitch that we experienced earlier will not actually be a problem, like where I tossed something in and the thing didn't react because it was turned off, and then I turned it on manually, but it was too late to react because the value had already been written. Now that works. Alrighty! Now what's missing is this. This thing shall suck the room dry when there's pressure in there. What do we need? We need a logic writer that writes the on state. What shall it write in there? I guess we need a logic reader, and we'll just use the pressure value directly instead of turning it into some logic thing. This might mean that this thing will never be evacuated, but I think that less than 1 Pascal is a tolerable mistake to have for the benefit of not needing a ton of chips. So we need a writer and a reader, and then we should be done. These chips are also rather cheap, though each one of them takes 10 watts when it's running, I believe. 1, 2, 3, 4, 5, 6, that's 60 watts, and this one only takes 50 watts, so that's less expensive. And also we can do tons more with that Logic chip still. It's with that MIPS chip, with the IC10 chip. MIPS, by the way, is a real existing programming language. It is altered and changed and stripped down or whatever for this game, so it's not actually MIPS as you know it in the real world, as a YouTuber pointed out. It's Stationeers IC10 MIPS assembly stuff. I mean, we know what we're talking about, right? Good. Logic reader, Logic writer. Cables, please. More than we have, obviously. So let's make some. It's hilarious. I mean, the good thing is, once we reach noon again, is the sun coming up? What? I'm stupid. Instead of staring at the sun for too long, which makes you go blind, you can just look here. 93. 93. Dude! Why is the angle not changing? Interestingly, even though the angle is not changing, it's constantly writing a value here, so I believe that noon will not be a problem, because it will be 0.0001, 0.1 or whatever. Maybe 0 will not actually ever be hit, so yeah, that concept works. If you need some always changing value, just use the day angle. Problem solved. Let's put the cables up. Do we need one down here? No. Down here? No. Yeah, not intended. That should be entirely wired up. Let's see. So, my goal is to read the gas sensor in there, which is called arc-furnace gas sensor. The variable I want to read is the pressure. I once again have to name that thing. Come on, I want to hit that thing. Pressure. And then choose it. Now we have the logic reader pressure as the input. The output variable shall be the arc furnace vent thingy. There it is, arc furnace vent. What we want to write is whether it's on. We should also write the mode, but I think that's just boring to just add another chip just to make this thing be in the right mode. Except might be interesting to enforce that mode, because maybe we can't use the day sensor. What mode do we need? We need one. That would actually work. I could use the same thing here. Hilarious. So I could just use another logic writer, use the same data source, which will work, and then write to that thing. But I'm not going to do that. So let's read the pressure. Or rather, let's first turn this on. Come on. Why doesn't this work? This is a really, really unnecessary annoyance. This thing is clearly sticking out of the glass. Yeah, it's getting a 0, but now it should be getting something else. Aha! That worked! That actually worked. So where did I toss the tablet? Okay, and this is also another thing that Rocketworks absolutely needs to fix at some point. I cannot pick it up because it is somehow occluded by that thing. Yeah, that's not right. Yeah, still some pressure in there, obviously. Why is the pressure decreasing? What could the reason be? Is the temperature decreasing? I have no explanation. Could it be a rounding error of the constantly running simulation? I wouldn't think so. Pretty sure that's in the realm of bug, if it would be so. Okay, what's happening here? Convection, radiation, temperature. I don't know why it's losing pressure. Doesn't make sense to me. Yeah, let's smelt something. $840 pascals. Not enough. But now it's enough. Alright. So that works. Mission accomplished. Entirely with these chips. It turns the thing on constantly. It reacts and activates it. It pumps it empty when there's no more pressure. It stops the pumping. And we're also gathering the gases. One last thing. Let's take some cobalt if I have any. I don't. I thought I had some cobalt, because then I would have gotten some N2O, because that stuff has that. Right? Nitrogen volatiles. Oh, volatiles. No, I meant something else. I meant silver. Silver has N2O. It has to smell 2 before the vent kicks in and sucks the room entirely dry. And we're getting some N2O. Okay, that's it for today. See you later, hopefully.